Hello, my name is Julian Motzelt. I'm a master's student in electrical engineering at the Friedrich-Alexander University in Erlangen-Nürnberg. Together with my supervisor, Maximilian Lübke, we examined the radar wave propagation of various antenna patterns in my bachelor thesis. Our goal was to compare different antennas with respect to the performance in RadCom applications. This means the combination of radar and communication. The main focus was the investigation of the communication. For this we used the tool Winprop by Altair. The Wallman vector database for the replica of the Leipziger Platz was created by Maximilian Lübke. With this replica we simulated different urban automotive scenarios in ProMan. Here you can see the 3D view of the recreated Leipziger Platz in Wallman. Two different vehicle platoons can be recognized, each with 10 vehicles moving towards each other. Car 4 and Car 5 in the right platoon were chosen as the transceiving and receiving vehicles in this scenario. For the cars we used the model of a Mercedes C350 given by Altair. To investigate the antenna performance based on the array size, Car 4 was equipped with a transceiving antenna at the front bumper and Car 5 with a receiving antenna at the rear bumper. First, we started with a small antenna array, a 2x2 patch antenna with high side lobes. The 3D antenna pattern is shown in the Altair Winprop antenna manager. As you can notice, the antenna pattern is not very focused, which reduces the antenna gain. On top of that, the strong side lobes of this antenna are evident in the antenna manager. To evaluate the results of the simulations, the impulse response is presented here. The strongest line of sight path shows a power of slightly more than -80 dBm. At a higher delay, we can still recognize path with a power over -130 dBm. These multipaths can reduce our performance of the vehicle-to-vehicle communication by increasing the inter-symbol interference. To overcome this disadvantage, we created more directed antennas. In this example, a 16x16 antenna pattern is shown, which was the most focused antenna used in my thesis. Building this antenna, we have to spend the largest number of individual antenna elements. In return, we get a highly directional antenna pattern and thus also a high antenna gain. So the setting remains exactly the same, only the transceiving and the receiving antenna was changed from a 2x2 to a 16x16 antenna array. Again, the impulse response of the simulation is used for the evaluation. Comparing the results, the 16x16 antenna shows a much higher line of sight path with approximately -60 dBm received power. In addition, the multipaths at a high delay above 300 nanoseconds show significantly less power, which minimize the inter-symbol interference.